All right, good morning. This is an algebra video for this week. We are going over the Pythagorean theorem and the distance formula. I am starting on page 303. And also, there was a mistake, thanks Mo. On the homework, it says page 303, but hopefully you figured out that it wasn't page 303, it was 306. Um, so I will put that mistake in the email tomorrow just to clarify, but most of y'all probably watch the video more than you read the emails. So just a heads up, in those emails that I send out, if I do have any mistakes or any announcements, that's where I put them. So even if you don't look at the YouTube video that I send out every day during the week, please read the notes at the bottom of them. If they are not your classes, don't worry about it. That's the only way that I get information to you other than a specific email to your class. All right. So we're going to start. I'm going to reverse this camera. Okay. Hopefully I didn't make any of you nauseous by the roller coaster ride. All right. So we have a Pythagorean theorem. If you want to pause the video so you can draw the picture, that's fine. Okay. I do want you to take notes on this. So again, this video is pausable. So just pause it if you need. So the Pythagorean theorem is a squared plus b squared equals c squared. First of all, let me explain. You have to have a right triangle. Right meaning it has to have 90 degrees in one of the corners. You cannot have more than one 90-degree angle in a triangle. It's impossible. All right. So you have to have one 90-degree angle for this Pythagorean theorem to work. It's amazing how God made shapes and triangles and circles, and somebody else has done the work to figure out a formula for them. So aren't we grateful? All right, we will always be labeling these, and we call them the sides of the triangle legs. Okay, so we will always label the legs A and B, and the hypotenuse, which is across from the 90-degree angle, is always labeled with a C. And if you want to write hypotenuse right here, so you know this is key. Okay, that's a U, not whatever you think it looks like. All right, so we have A squared, the side right here, plus B squared, this side, equals C squared. This is always true in a right triangle. So let's say, for instance, like the book example, we have A is equal to 4, B is equal to 8, and we need to find C. So you would do 4 squared plus 8 squared equals C squared. All right, so then this is 16 plus 64. All right, and so then you would add that together and you would get C squared is equal to AB. And in order to get rid of this square, we want to square root it and square root it. Okay, so I'm going to bring it over here and write C is equal to the square root of 80. Now, one thing that you need to remember from your times past, like last week, is this is not simplified. Okay, how do we know it's not simplified? Well, you should know that 8 is divisible by 4. Okay, and so I can actually take out 4 and do this. Okay, there's another number in there. You see, this is another 4. Okay, so if you didn't see right at the front, which I didn't, honest, 16 times 5 is 80, right? Okay, so when we have 16 times 5, like this, we are going to go ahead and take, what is the square root of 16? Well, that's 4. So we're gonna take 4 out, and this is our C. Make sense? Okay, so then we will work another problem. Okay, I'm going to actually look at your book and make sure that there's nothing that I want to work. over another. I'm going to actually take one of your homework problems. All right. I'm assuming it's a homework problem. I don't have your lesson plan right in front of me, but it will be a blue problem. All right. So let's take a look at, let's do number 2. Okay. So we have a triangle like this. Okay. We have 1 and we have 8. And this is our x. And we're asked to find the value of x in the right triangle. Okay, we know these two are legs, and what I would suggest you do so that you can start to memorize this formula, because yes, you have to have this memorized for math class. Okay, it's one that a lot of people, even if they stop doing anything with math, they have this one down. Okay, so c squared, which is our x, we're going to say x squared equals a squared plus b squared. I don't care whether it's the 1 or the 8, so we're going to go 1 squared plus 8 squared. Okay, so then we keep writing x squared equals, what is 1 squared? Well, that's 1. What is 8 squared? That's 64. And so this is 65, right? Okay, so we want to just find x. So x is the square root of 65. Okay, before I leave it in this form, I want to make sure that I can't find a perfect square in here. I know 5 can go into it, so I'm going to come over here and do 5 into this, and that is 13. Whoops, I don't know why I did that. So 13. Neither one of those are perfect square, so this is simplified, and that is our answer. Okay, I would like to work another one like number 8. Number 8, I don't believe is part of your homework. Okay, but it is a very interesting problem where your x is one of the legs, and we have this. All right, so again, c squared equals a squared plus b squared. I want that formula written. Okay, and then fill it in. Our c squared, 12 squared, equals, and I'll just put it in as the a, plus 9 squared. Now, be very careful. 9 is a square. Don't think, oh, well, 9 is already squared. You don't have to square it again. Don't do that. Okay, so 144 equals x squared plus 81. Okay, I'm going to flip things around, so it's going to look like this. If you don't want to flip things around, that's fine. Okay, so then I'm going to pull 81 over here. Okay, and at this point, hopefully you would go, oh, well, I can put that into my calculator. I hate subtraction. Let me just say that. Okay, especially when I have to do it, you know, in front of you. Okay, which I do all the time, but you know, that's besides the point. Okay, so we have 63 is our answer. Okay, now that's x squared. Don't forget, we're not done. Okay, all right, now 63 has a perfect square in it. How about we divide this up to what we know, and hopefully you recognize that 9 was the perfect square. So look at it this way. Okay, this is practicing what we've been doing the last couple of weeks. What is the square root of 9? Well, it's 3. Okay, so my x is equal to 3 times the square root of 7. This looks like I'm circling that, but no, I'm not. Okay, so that's our final answer. All right, now on the bottom on the graph, I probably need some more paper. Okay, on the bottom on the graph, on the chart, I'm sorry, not the graph. So let's say, for instance, you're dealing with number 10. Okay, it tells us leg leg hypotenuse. Okay, and it says the leg we don't know. Okay, this leg is 8 and this leg is 11. Okay, so you're going to, again, a squared plus b squared. Don't you love it that we're writing the formula? You're memorizing it as we write it. Okay, one of the legs is this question mark. Let's leave it as A. It doesn't matter. You can put it as B if you're feeling that way. And then C squared is always going to be this. Now, notice on this, I went ahead and squared my 8, put it there, squared my 11, and put it there. However you want, you can do it. Okay, this is, subtraction again. I think I don't like subtracting in front of people because it's very possible to make mistakes and I don't have y'all in front of me to correct me. Okay, so we have 11, we borrowed there, and we're going to borrow again. Okay, so we get 7, and we have this. Okay, now 57, first of all, square root. Can you think of anything that goes into 57? If you're like, oh, it's a prime, it's not a prime. Okay, 5 plus 7 is 12, and 12 is divisible by 3. Okay, so we know 3 goes into this. So we're going to just check it just for safety measures. Okay, 3 goes, you have a calculator, so hopefully you are using it. Okay, 3 times 19, well, 19 is a prime. 3 is a prime. So we are done with our answer. So that's number 11. Okay. Next part of the lesson. This is distance formula. And this you're going to put in your notes. I kind of misspelled distance. That's an N, by the way. It looks like a A-N. I don't know. Okay, so distance formula. I'm on a roll. Where's Abby when I need her? Okay, so what you need to look at is you need to look at page 304 to start with. Okay, they have pictures of the dots and they're going like this and they're going straight across, or you don't have to draw this. Sorry, I'm putting this as if this is your notes, but it's not. Don't worry about it. Okay, you're doing the distance between these 2 points, right? And you could count, and it goes from -4 to +5, which is a distance of 9, right? And then over here, the distance, it goes up from 5 to 9 on the y-axis, so your distance is 4, right? Well, if you go to the next page, 305, it gives you this distance formula, judging, excuse me, had to cough. Okay, judging as if it was a triangle, for instance. Okay, so they kind of made this a triangle, and they kind of made this a triangle, and they came up with this formula with this being a right angle, and this being your C and your C, and this is your A and your B and your B and your A, but usually distance formula is not that easy where you can calculate this or this. Usually your distance is from one point like here to another point here. Okay, so then your formula would be this. Okay, this is your change in y and your change in x, and this is your distance. Okay, and they are using this formula basically. I'm going to write it like this. Okay, x squared plus y squared. Okay, and then in order to find d, the distance, what they've done is this. Okay, but how would you know that this is x? Well, it would be easy if this was the x and y axis and this was 0. It'd be easy, right? But normally things aren't easy. And normally things are maybe like up here. right? So you would have to go the change in y over the change in x. Okay, well, so again, I said I needed more paper. I think I need more paper. This is my 4th video this morning, so give me a moment. Just hold on one moment. I'm going to get some more paper. Okay, here we go. Okay, so this formula, this is what you need to write down as your distance formula. I can redeem my spelling, right? Distance formula. Okay, right there. Is D is equal to the square root of x squared, not squared, scratch that, x2 minus x to the 1. I want you to put this underneath it so that you remember this is the change in x. Okay, remember, if we ever have to do change, we are subtracting. And notice we have y1 and y2 and x1 and x2. Whatever order you do here, you have to do here. Okay, it doesn't really matter if you did x1 minus x2, as long as over here you did the same thing. Okay, don't forget that squared. So this is change in y. Okay, so for instance, if we are finding the distance between 2 points, I'm going to use the 2 in the book. Okay, I like them because, one, they have a negative. They deal with negatives, and you need to get kind of used to that. Okay, so there's our formula, the distance between these 2 points. Let's just kind of look on a graph. You do not have to graph these at all. Okay, but let's say 5, 4, that would be over 5 up 4. The point would be about there. Okay, and this would be over 2 down 1, and the point would be here. Okay, so it's asking us, what is the distance between these 2 points? And the reason it's not super easy is we really can't count. These are not spaces that we can count. Like we could count this way. That would be 2 over, and then over here it would be what, 5 more. Okay, so this would be 7. Okay, this way, and this way, this is 1. Okay, so this is our down 1, and then this is up 4. 1, 2, 3, 4. So this is 5. Okay, I'm not going to use this right here yet. Okay, but I want you to kind of envision this. Okay, so in fact, those of you who are willing to write this, go ahead and write this down. It might not be a bad idea. Okay, so distance equals, and yes, at the top of your page, just so that you can avoid writing this every problem, write this at the top of your homework page. Okay, so also, this is your x, this is your y, this is your x, and this is your y. And we'll label them like this. Okay, all right. So you don't have to label them in your work. It's not a big deal as long as you don't get them mixed up. Okay, so here we are. We're doing the square root of the difference between these two. Now watch what they did. They subtracted. So this would be 5 minus a negative 2. Be careful because that was already a negative. That doesn't take place of your minus. You have both of them. Okay, squared plus, okay, and we're going to do our y's. You see how we did 5 minus a negative 2? You've got to go in the same direction. So if we went this direction, we're going to do the same direction. So 4 minus a negative 1. 4 minus a negative 1. We're going to square that. Okay, so what happens when we have these two negatives? Hopefully you said they became positive. Same thing here. Remember our crazy clown face? All right. So we have 5 plus 2 is 7. What? That was over here. Don't forget, you have to square it. Okay. So let's do this. This would be 49. Okay. Now, 5. What? We figured that out over here. So this is 5 in the parentheses. What's 5 squared? That's 25. So I'm going to come over here because my calculator is on my phone and my phone is charging. So we add these two because that's in the formula. Okay. So, all right. 4 plus 2, 6, 7. Okay. So we have the square root of 74 is our answer. Now, you know 74 is an even number. The book ends there because it doesn't divide out. But let's just say we didn't know that. Okay, so we need to kind of provide some more evidence that it doesn't divide out. So 74 divided by 2, it goes in 3, 7, 37 is a prime number, and that's why we know that this is good to go. Okay, let's work a problem from your homework that is a distance formula. Okay. I'd like to work 16 or 21. 21 is very similar to the one that we just worked. So I'm going to use 16 just so that you can do something different. Okay, 16, and that's our last one that we will work. I wish I had my, here, found my lesson plans. Okay, so let me see what I have assigned for you. Lots of stuff going on. Okay, this is what I do. I don't know if any of y'all do this. I staple all of my week 6. This is 6. Anyways, I have all my lesson plans stapled and kind of together. I don't know where I put them right now. Oh, yes, I do. I'll even show you. Okay, watch. This is all stapled so that I can keep them straight. I don't know how y'all are organizing, but sometimes this is getting a little overwhelming to me to have so many different papers. So I just go ahead and staple them every day. Sorry about all that movement. So here's my week 2, then I have week 3, then I have week 4 if I was in order. See, week 4, see? So I'm trying to stay organized like that. You might try to do that. Okay, back to what I got off topic to see. You right here, remember this is 306, not 303. And then your 307, 11 through 30 is your second assignment. And it is definitely, it's on the, well, I say definitely, yes, it is on the next page, and I have you reviewing. So 11 through 30, blue only. Okay, all right, so back to number 16. Okay, 16. Remember what I said, have this at the top of your paper so you don't have to rewrite it. X2 minus x1 squared plus y2 minus y1 squared. Okay, all right. So once we have this, I'm going to write my 2 points. Okay, hopefully you remember that these are 2 points. I'm going to draw them, but I'm not going to do the 7 and 5 thing like I did before. You can, but you do not even have to draw them. So 2, -1, 1, 2, -1. Okay, there's my first point. And my second point is straight up the y-axis. Okay, so it's actually this distance right here that you're trying to find. Okay, how long is this? That's what you're solving for. Okay, so we are going to put in our work. If this is x, 2, x1, y2, y1. Okay, I did it a little different just so that you can know you can move things around as long as both of them over here, if this is x1 and y1, and this is x2 and y2, but I switched them up, okay, because you can switch them up. All right, the difference between 2 and 0, okay, so we're going to go 2 minus 0, we got to square it, okay, plus the other way. So you know how here, I'll try and move this up. We went this direction in our subtraction. I'm going to go this direction in my y. So -1 minus 3, and don't forget to square. Okay, so what happens here? Well, that's just 2. What's 2 squared? Good, 4. And then this, -1 minus 3 gives you a -4. What happens when we square negative? It becomes positive. So this would become positive 16, and the negative went away. Okay, so then we have the square root of 20. What? Hopefully you see right in here, we have a perfect square. What's my perfect square? 4. Okay, so I want you to see this, because those of you who are still not getting this really need to understand this. This is the same thing. Okay, what's the square root of 4? Well, it's 2. What's the square root of 5? Well, I don't know. It's not a round number. Okay, it's a very irrational number. So this is our distance. So if you were wondering, I don't have my calculator again, if you were wondering how long that is, stick this in the calculator, 2 times, and then hit 5 in the square root of 5 button, okay, and multiply the 2. It probably is close to 5, okay, like 5 away-ish. It'll probably be, well, I know it'll be a decimal, but you might check that out and see if that works, okay? All righty, we are done. Have a good day, all right? Hopefully you won't work too hard, but hard enough, okay? If you do have questions, please remember, I'm gonna flip this around, okay? Please remember, we do have a Zoom video tomorrow, Tuesday, at 11:30 a.m. Okay, you do not have to show up if this is perfectly understandable and you have no questions. Okay, if you haven't done this, or if you haven't even watched the video, you're probably not going to help you to show up, because I will be doing specific problems that you're asking, and if I've already worked them on the video, I will not rework them on the Zoom video. So have a great day. Hopefully everything will make sense. If not, you know where to find me. All right.